We all know a language model can answer questions about design rule checking. The question I wanted to answer was a different one. Can a model actually run a real sign-off flow? Not describe it, not generate a command for you to paste, but run it and come back with an answer grounded in the engine's output? That is what the next 5 minutes is about. Here is the gap. A model can explain a design rule, and it can write a plausible command line. But it has no deterministic path into the tool that actually performs the check. The obvious answer is to make the model better at DRC, to train it until it can do the job itself. We deliberately did not do that. We kept the model on the reasoning side of the boundary, and kept execution in the deterministic engine. And I want to address the obvious objection. You can probably get a capable frontier model to call a DRC tool today. I agree. Calling one tool is not the interesting problem. The problem is maintaining an orchestration layer across 20+ engines, each with different inputs, outputs, and capabilities. That quickly becomes a maintenance problem. Our approach is to make the tools describe themselves, so adding the next tool is closer to adding a tool than writing another orchestration system. The shape is deliberately small. A request comes in, the model reasons, selects a tool, and emits a structured MCP call. The MCP layer invokes the real engine. The engine computes deterministically, the same way it would if you had typed the command yourself. The model then observes the result and reports what the engine found. Notice where the model is and where it is not. It chooses at the front. It explains at the end. It is nowhere in the middle, where the answer is actually computed. The important scaling property is that we do not write a new orchestration layer for every tool. The tools expose their contracts, and the model reasons over the available surface. This is an actual run, not an illustration. A SemiKong 8 billion parameter model, hosted locally, was asked whether a layout is clean. There was no tool-specific fine-tuning, no prompt library, and no hard-coded workflow. The model selected the DRC tool and generated the structured invocation. The engine returned the verdict. The model reported the engine's result, not its own. The important point is that the model did not produce that result by reasoning about geometry. The DRC engine did. So, 3 things to take away. It is model-agnostic. We ran the same architecture with a small local model and with a frontier cloud model, and the answer came from the same place both times. It is tool-grounded. The answer comes from the engine, and because the engine can fail a check, the system is also allowed to refuse rather than hand you a plausible guess. And it is local, which for most people in this room is the difference between deployable and not, because your layouts and your process kits never leave the building. I should say plainly that this is a work in progress. And the newest piece of it is that we have now integrated OpenRoad. We drive it directly, rather than wrapping it in scripts. Everything you have seen is installable today, and the links are on this slide, so please go and run it yourself. If something you need is missing, tell me what the use case is and I will look at it. The line I would leave you with is this. The language model is not the sign-off engine. It is the driver. Thank you.